Thank you very much. So for all the guys that are inside this big room, and today we will talk about Elixir. So I'm very happy and thank you to be here. Also, if we are out of context, because clearly this is a conference of Plone, but yeah, I am very happy to be here as a guest. So 2 words about me. My name is Gpad. I am the CTO and founder of Coder 51. I like to develop code, and especially in distributed system. And in the last, so probably 5 years, I have worked almost all my time with Elixir and Erlang. So today I will talk about Elixir. Very easy introduction to this code, and from the website of Elixir. This is the description of Elixir. That is a dynamic language, functional language designed for building scalable and maintainable application. Elixir leverages the Erlang VM. This is very important because Elixir is a quite young language, because it was developed around 2012, so 6 years ago. 6 years ago, but Erlang, as we see in a bit, it is a very old language that started, the last millennium. So, a lot of history. So this is the history of Erlang. It is very important because Erlang is the base and the background of Elixir. So the first experiment was on 20 different languages around the 82 and 85, so 1982, 1985. In the 1985 and 1986, experiment with Lisp, Prolog, Parlog. Parlog, it is not a typo. There is a language that's called Parlog. So the conclusion is that the Ericsson require a language with a lot of concurrency and error recovery primitives inside this language. So in the 1987, first experiment with Erlang. In the 1990, Erlang is presented to ES90, that is a very big conference, which results in several new users. In 92, Erlang is ported to VuixWorks PC, Macintosh, and 3 applications using Erlang are presented. So a big success. In the 1993, distribution is added to Erlang. So there is a feature where you can start program in Erlang and create a cluster in Erlang. And this feature was added to the language in 1993. And the rest is history. So just to be clear about the time frame that we are talking about, so 1982, we are winning the 3rd World Cup in Spain, not in Berlin, so 1995, Back to the Future, and they are trying some different language. So first experiment with Erlang. We present Erlang to the conference. So Schillaci is happy for Erlang. Yeah, Erlang. And 1982, Rage Against the Machine released their first album, and 3 applications was developed with Erlang. This is not a coincidence. And last but not least, 1993, Doom was released, and it is the first release, not the last very hype. So the first, just after Wolfenstein 3D, 1993, and Erlang has inside the language the distribution. Okay? So just to compare with the other language, Java was released in the 1995, so 2 years later, and the first version was more or less the same. Don't use it because it's broken. So the years before, the years after, in the 1996, the first Java version was released. So 3 years after that, Erlang has the distribution inside their core. And yeah, .NET, it's a child, okay? And yeah, Python was released inside the 1991, the first release. So yeah, it is more or less comparable. Okay, so Elixir is a functional language. What does it mean? That we have immutability. So probably this is the first things that a programmer that came from an objective-oriented language struggle with, because you have a variable, and when you assign a value to a variable, this variable is immutable, and you cannot change anymore. So yeah, it is very difficult. But if you think, a lot of immutability inside the actual object orientation language, so for example .NET, Java, and a lot of other things was added. And so it is now a very strong paradigm to use inside also the OP. So for example, there is a lot of libraries that give you some immutability in your structure. And also if you think, for example, string is already immutable in a lot of not functional language. And so the question is, why immutability is so important? Because if you have immutability, you can pass your value and your variable without any problem to all the other function, okay? Because you can pass, and the other function cannot change it. This is a very good feature. And yeah, in the beginning it is too difficult, but when you return to the language without immutability, you miss it a lot, in my experience. So another part of Elixir and Erlang is pattern matching. It is quite common in all functional languages, and also other language as pattern matching. But inside Elixir and Erlang is so strongly used that we will see in some example that pattern matching is used also when you don't think. So for example, Elixir and Erlang, they don't have the assignment. They always do pattern matching. Okay, so when you assign a variable, in reality you are pattern matching between a constant and a not assigned variable, or not binded variable, if you want to use a correct terms. So the other part is recursion. So in functional language like Elixir, you don't have the for. You have the for, but it's not. It is something like list comprehension. So it is not a for. You don't have the for. You don't have the loop. And so you should use the recursion. And clearly, you have another very interesting feature that is macro, and especially in Elixir, that is come from the Lisp world, when you can take your code and change your code whatever you want. It is not a simple metaprogramming, but is really something like Lisp, when your code is your data. During the compilation phase, you get your code with an abstract syntax tree that is abstract, that you can change, you can manipulate, and so we will see some example. And yeah, you have a lot of different library, like enumerable streams, that is quite useful in a functional language, and a lot of other things. But yeah, we are not able to change the value of a variable, and we don't have global variable. So where do we put our state? So this is something difficult, for example, for a guys that come from OP world. And how can we share the state? We cannot share the state. This is something that we will see. And yeah, so all my presentation is inside the console. And I hope that I can mirror the screen, but for some technical reason, I was not able, so please forgive me or forget me. It's depend. Okay, so just to give you some example. Okay, oops. First problem. Okay. 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 So this is how we declare a map inside inside Elixir. Okay, and we can change a map like this or like that. So if you take these two commands and we try to execute it on the shell, okay, we will see that we declare a map with a key and a value, so it's very simple, it's very straightforward as syntax, and we create a new map, okay? The third instruction more or less change the map, but it is not true because we are not able to change the map. We are simply rebinding the variable. Okay, I will try to give you an example. Okay, if we declare a map and create another variable called p, okay, and again we change the m is changed, but p remain the same. Okay, so every time that you can change something in Elixir or in general in a functional language, you create a new variable. Okay, in a lot of language, this is the usual behavior of the string. Okay, I don't know if in Python is it the same, but for example in Java, in C# you are not able to change the string, but you always create a copy. In this case, all the variable that you change create a copy. This is clearly a copy, a logical copy, and not a real copy. Inside the virtual machine managed all the details of this copy, but it is a very interesting thing because, for example, if you pass this variable to a function that makes some work on this map, you are not you don't take any problem, because if the function changes the variable, create a different copy, and you remain with your variable. Okay, so it is something very, very useful if you start to think in this way. Okay, so this is the pattern matching. So we create always our map. Okay, and yeah, we create oops, sorry, we create our map, and how we can extract, for example, some data. I lost the mouse here. Okay, how we can extract some value from this map? We can do it using the pattern matching. So we can get these things, and inside V we have the new value. Okay, so we are not assigning something, we are making pattern matching. And this is so true in Elixir and Erlang that we are always pattern matching and not assign. Okay, so we can extract inside the V variable the value of the second key, so the B key of the map. Another struct that we can use inside the Elixir is the Tupple or Tupple or whatever you want. So probably you know it from Python, but in Elixir and also in Erlang, the tuple is more or less a list that is keep continuously in memory. So this is something that you can move all together with inside Elixir and also inside the virtual machine of Erlang. And opposite to this, the list is implemented like a linked list. So it is very easy to, in the list, append and remove a variable, because you can only change the pointer. But in a tuple, if you remove or if you had some value, it is a little different as a performance. So, for example, a tuple is used like a struct in C, and the list is used like a list, more or less. But yeah, so we can, using the pattern matching, for example, we can extract the value of the second term of the tuple. And yeah, again, and as you can see, we have changed the value of V. So the V is rebinded, okay? How we can, for example, don't do it in this way. So if we can re-get the value from the map, okay? So V now is 2, if I remember correctly. And now if I try to match, putting this strange operator, we get an error, okay? Because we are saying to Erlang, okay, make a pattern matching between T and the second value of the T, that is a tuple, contain the value 3, and this type of tuple, where the first element and the last is almost whatever you want, so this is the underscore, but the second element, I want to be the value of V, the actual value of V, that is 2. And so Erlang say, oh, I'm sorry, I'm not able to do the pattern matching, okay? And this is something that you can get very, very often. And the pattern matching is so deep inside the code and inside the virtual machine that you can use also in a lot of different instructions. So for example, this is the case, and that you can think more or less as a switch, where the res in this case is a tuple like OK and 42, and is quite often in Erlang and Elixir return from function a tuple that describe the return with, for example, OK and the value, or as we see in the last line, error not found. And we can do pattern matching on the shape of the return. So we have, for example, res, and in this case we extract inside the value V the second value of the tuple. Otherwise, if we are not able to pattern match these things, we go on the other pattern match. Okay. And again, we can try. So we can skip because it is difficult. But yeah, again, in the function definition, we use pattern matching to select the correct function. So the virtual machine select the function the first functions that are able to pattern match with what we are doing. So if we define, for example, in our console res in this way and define a module, where a module is more or less a container of all your function, okay? And yeah, we define our function, and we call the function with res. Okay, res now is OK42, and as you can see, the compiler, the virtual machine, not the compiler, sorry, the virtual machine select the first function because it is the best pattern matching that you can find. And if you change the value and change the shape, okay, sorry, if I, for example, here put something like, yeah, also like this, error, and recall the function, the other function is selected. So the pattern matching is from the beginning, from the top to the bottom. So the first pattern matching that the virtual machine can execute will be executed, okay, and yeah. So this is, for example, an example to how to get the actual date, and as you can see, we return OK and the value, and inside yesterday we have yesterday, and so we have a lot of other things that yeah we can do. Clearly, we have a module for extract the keys from the value. Okay, as you can see, the parentheses are optional. It is not quite common omitted, but sometimes you can. And yeah, just to finish, I want to show you something about the recursion. So suppose that you want to create a function to sum all the value of the list. How you can do it? More or less like this. So create a function that is called sum, that receive a list, and it is a quite common pattern inside Elixir when we implement the function sum with another function that is called do and same name, so do sum. And as you can see, again, we are using pattern matching. So if we receive a list empty, we return the sum. Otherwise, make pattern matching with the value inside the calling function, because we are destructuring the list, extracting the first element and all the rest of the element, and we add the actual values of the sum with the first value, and go on. As you can see, we implement a loop in the recursion, and also without an if. This is another feature of Erlang virtual machine, that is the tile call optimization, where this type of recursion can be expressed without keep all the stack, because the state is only in the variable that you receive, and so the virtual machine throw away all the stack. And so, for example, if you want to create an infinite loop, you have to call yourself, because you don't have the while. So just to run it and to see what happened. Okay. Yep. And okay. As you can see, we have an example. So first, we have make the sum of the very simple list, that is 1, 2, 3. And then we have created a range, that is another construction of Elixir, that is a not a real list, but is a range that start from 1 and go to 10 million. Yeah, and then we made a call of the same function before converting the range from the range to the list. And as you can see in this example, it is something that you often do in a functional language, especially in Elixir or Erlang. And so you transform your data from one struct to another. So we start from a range, we create a list, and we pass this list to the function, and we get the result. As you can see, it is not so good to read, because you should read from the right to the left, and it is not useful for us, especially if you go on and we can skip this part, but for example, if you go from this part, okay, and we try to do something like this. So we have a list, we want to map to a lot of different values. So in this case, we are double it, and we want to filter and keep all the value below the 10, and that at the end sum. As you can see, we have to use a lot of temporary variable. If we want to omit this, we should do something like this, and it is not very simple to read, okay? So if we try to write something like this, we get the same result, but it's quite difficult to read, because we should again read from the more or less from the end, okay? because we do something like this. If we think about this type of operation, and we are in the 50th anniversary of Unix, Unix solved this issue using the pipe operator. So if you have a program, and you want to take the output from the first program and put it as input for another program, you use the pipe operator inside the bash, okay? And we have almost the same things in Elixir. And, oops, this is more readable. But it is the same because the pipe is a macro. And they take your language, they take your code and change it on the fly. But in the reality, they create the first call. It is always the same. And you can see you omit the first parameter of the function. Okay, so we have the list and we put it as first parameter of the map. The result is the first parameter of the filter, and the result is the first parameter of the reducer. Okay? And yeah, you start to think in this way. Okay? So, okay, we can transform very easily our data. How we can keep our state? So, if we think about a very simple Python code, this is the best that I can do in Python, sorry guys, but this is a counter, okay, very simple. We can increase a value and keep the count of how many times is the value is changed, okay, and this is something that you can do in Python. But if we can try do something similar in Elixir, how we can do it? Because we cannot change the value. Oh, it is quite simple, because we create a module that return a struct, in this case a map, sorry, that is the state, and we always have to pass the state to the other function, and the function returns the new state. And it is a very big improvement, because I read a book about closure that is something different, but yeah, the idea is that in functional language, you have more state than a object-oriented language, because if you think when you change the state, you lose the previous state. Okay? In the program before, when you increment the counter, you lost the value before. Inside a functional language, you always keep your history, and you can go forward and backward. So if there are some front-end guys that use the React with Redux and the time travel machine to go back and see what happened in the debugger, it is based on the same idea. So every time that you change the state, you keep the previous state. And it's quite easy do it in Elixir, okay? So if we, for example, declare this module inside our virtual machine, and we try to do something like this, we will see that, yeah, we return always the same value, and we not proceed. If we want to go on, we should pass the value, or using the pipe operator, we can do something like this. Okay, very easy. But you can always back in time. But you get almost the same result as a not functional language, okay? So, functional example. This is some idea, some constructor of a functional language like Elixir and Erlang. Okay, so, sorry. From the website, okay, Elixir is a dynamic functional language, as we will see. We have seen we don't have type, we have functional language, but yeah, this is designed for building scalable and maintainable application, low latency and distributed and fault tolerant system. So how Elixir and Erlang can reach this level of scalability and fault tolerance and yeah, all the buzzword that you want. So using the process. The idea is that inside your virtual machine, of Erlang virtual machine, you create a process that is very similar to an operative system process for some aspects. So, for example, it is isolated. If the process crash, the other process is not affected. All the data that live inside the process are owned by that process and are not shared with the other process. So it is very similar to the process of the operating system, but it is very light. So it is very easy and it has a very low level of resource required to create a process. So inside your virtual machine of Erlang, you can easily spawn 2 million of process without any problem. Okay, so another tool that is related to the process is linking and monitoring. So you are able to link two processes together, or you are able to monitor two processes together. We will see in the next demo. And yeah, the message passing, it is the only feature that you can use to exchange data between two processes, because the processes are isolated and you are not able to share data between processes. And if you want to exchange it, to share but not share, so you should send a message to another process. And the distribution, because this is the low level, so this is the low level thing that you can use to create your distribution, because now you have a building block that is the process, and if the process is local or remote, it is not so different. You always send a message, okay? Because a lot of problem that you have locally, you have also remote. Clearly, if you go remote, you have the network latency and so on. But also locally, you have to take care, for example, that the process is done. The process is dead. And so you send a message that the process is not still running, and so you have to take care of the timeout and something like this, also locally, okay? So last but not least, the Otp library, that is the library, the standard library of Elixir and Erlang that is built above all these things. So yeah, again, we go back to our shell. Shell is our friend, okay? So if we, for example, declare this module, as you can see here, we are creating a module, okay, that are using the infinite loop, so the recursion to create an infinite loop, okay? If I call this function inside the shell will hang up, okay? And so I will create in two different processes, okay? So I spawn. As you can see, we are using the spawn, that is a function, that receive another function. And as you can see, the value of the two counter are changing in a different way. So now I kill the process, otherwise the shell continue to grow, okay? And now, as you can see, I killed the process was killed, clearly. And as you can see, for example, in the PID, that is the identifier of the process. So the first PID, I don't see from here, but yeah, there is the count 23 that for one process is 1,250, and the other 23 is 996. So the two counters are not related together. And for example, locally counter remains 0. So when you start the process, the data is copied, and yeah, they live alone. How we can exchange data in this way, creating another module that receive the data, and yeah, when we call it, we pass our PID to the spawn, okay? And as you can see, we receive the message from the other process. And so we can, yeah, we have a lot of process, we have a lot of message, and so we have a primitive like receive that extract the data from the message. So we have only 5 minutes, so we go fast. And yeah, you can create and link all the process together. What is the difference between link and message? Very simple. And monitor, sorry. If you spawn to monitor, as you can see, you receive the PID and the reference. And when you kill the process, you receive a message that say, hey, this process is dead. When you link to process together, as you can see, if we kill the process, also my process is killed. As you can see, the shell is restarted because the shell was linked to the other process. Using this building block, we are able to create a lot of different things. So for example, things about a process that monitor or are linked to another process. Okay, using the Otp library, we are able to create a lot of different things that we will see in 1 minute. So the Otp library, starting from GitHub, is a library that contains a lot of different things. One of the supervisor, that is the process that monitor the process, Gen server, Gen state machine, that are process already built that you can use to create some behavior, or for example, to create state machine, and there is a lot of different things. So I have created an example that is written in Elixir, Phoenix, and I have, this is a very simple web application that has 3 URLs, and suppose, and it's deployed, so it is running on the web. Suppose that this library has a bug, okay? This is the library, this is the application, so give me 1 second, please, yep. Okay, and I go here, okay. Okay, this is the application. Where is gone? Oh, I lost everything. Sorry. Oh, fuck. Here. Okay. So, okay. Move to a new window. Okay. Frozen? No. Okay. Okay. Ah, sorry. Okay, you can see it here. Okay. Okay, so this is an application that was deployed, and as you can see, there are 3 links, and you discover that when your application is already deployed, there is a bug. Okay, and the bug is here. So I supposed to have a bigger screen, but yeah, a big resolution. Sorry. So yeah, there is a problem. It is written Gpad sucks and it is not so good. Okay, so I want to fix it. And I want to redeploy my application, okay? So, okay, what can I do? Clearly, go to the machine, okay? And, okay, I move to SSH and to the machine, okay? Inside this application, there is the deployed application, and we can easily start. If you know Rails, and also I think Django is able to create something like a console for that is a process similar to the application process that run on the same database. Okay, and so checking your your data, you discover that that your application use some wrong data on the database and you want to fix it, okay? Suppose that you want to fix it, and yeah, you go here, and so you can make something like this, and yeah, gpad, okay, and so we can list settings, okay, and we discover that this setting is wrong, okay? Okay, and we can clearly update settings, and we fix it on value, oops, sorry, value, yep, e mettiamo rocks, ok, yep. Oh, what is, sorry, what happened? Ah, okay. 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 So I change it, and if I go to the online application, as you can see, rocks. Okay. And yeah, we are happy. This is something not so fancy, okay? Because it is something that we can do also in a lot of different language. Okay, 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 go on. But yeah, suppose that we have something in memory. So inside your process. So memory, get value from gpad. Okay, sorry, but and yep, we get sucks. And if we go here and we go back to home, if I able to go back to home, okay, here, and we go in memory, we get the same result, okay? Okay, so I can change it, yeah, because we are on the same virtual machine. So we had sent a message to the process and we change it, okay? Last but not least, we are also able to change the code, okay? If we can, as you can see before, we are able to copy the code in the past, and the last example, but we are running out of time, it is, we are able to change the code on the fly. And I think that is something that other languages are not able to do. So yeah, just a recap. Use the function mindset, so pass your data. Think not to share data, but pass it around. Try some library in your ecosystem. So there are some libraries that take this idea inside the Python library, or try Elixir if you want. Okay? So thank you.